Hola amigos, welcome to the third chapter of my tutorial series about Substance Designer. This software by Algorithmic, now a part of Adobe, is a powerful tool for the creation of procedural materials like the ones you can see here, and it is used by video game studios and VFX companies all over the world. Since the 2021 version, it can also be used to generate procedural meshes, but we'll focus on materials for a few videos. Substance Designer is available with a subscription model from Adobe Creative Cloud, but can also be purchased with a year of updates from the Steam store. At the time of making this video, it cost me 171 Canadian dollars. What makes Substance Designer different from most texture tools is that it uses node graph in a non-destructive way. You can think of these nodes as actions, like combining two layers in Photoshop or applying a 2D filter to the image. For example, if I wanted to change the blue color on this material in an image editing software, I would have to select the blue area and manually create a mask to include the dirt and imperfections, which would take a while. However, in a non-destructive graph like this one, I can simply go to the nodes that define the color and change those, without touching other part of the graph, in seconds. And in a similar way, I can edit the patterns, add or remove dirt, and any change would propagate along the graph. Let's create a new material so we can examine the different parts of the user interface. From the File menu, select New Substance Graph. I will explain this window in more detail later, so for now just select the Metallic Roughness template, give it a name, and click OK. Don't worry about the rest of the options for now, those can be left to default. Let's start with the Explorer panel on the top left area. This window lists all the files that are currently open and all the graphs contained on each of them. Right-clicking on a file will show a context menu with useful operations like exporting, publishing online, or saving. The Explorer panel also shows all the outputs for each open graph. Since we use a template, the graph already has a few outputs connected to default values. The main part of the interface is the graph view, where all the magic happens. To pan the camera around, press and hold the middle mouse button. You can also zoom in and out with the scroll wheel. Note that the view will zoom toward the position of the cursor. The top row of icons in this panel has commands related to the graph itself, such as focus on selected nodes, export the graph as an image, search nodes by name, or different alignment tools. It also has options to display more or less information on each node and a shortcut to export the output nodes as images. As you might have noticed, some of the nodes have icons on the top. The box-looking one means that it's currently used in the 3D view, so it is an output node. To select a node, left-click on it. This will add a new file icon on top. This one means that its properties are currently shown on the right panel. Next, double-click on a node. Next to the properties icon, there's a new one with a checkerboard pattern. This means that this node is currently shown on the 2D view panel. To connect nodes, simply drag and drop from one of the ends of the connection to the other. You can also connect the out value of a node to multiple inputs, or move an existing connection by holding the Shift key while dragging one of its ends. As we just saw, the Properties panel on the right displays all the attributes and parameters of any node selected. Most nodes have a set of common properties at the top listed under Base Parameters. Next, the specific parameters for that node. And finally, any custom input values that you might add. We'll see about that last part in a future video. For now, I'll just change the gray base color for something nicer by selecting the Uniform Color node connected to the first output and adjusting the values in the Properties panel. Below the node graph, on the right side, we have the 2D view. We can navigate this panel with the same controls that we use for the node graph. Remember, middle mouse button to pan and scroll wheel to zoom. By pressing the spacebar while this panel is in focus, it will expand the current texture, allowing you to see how it tiles. The next panel is the 3D view. This one has a few more controls for the camera. Press and hold the left mouse button to rotate around the center of the image, and use the scroll wheel to zoom in and out. You can also move the camera around with the middle mouse button, and forwards and backwards using the right mouse button. The default scene has no lights, but you can rotate the image background that illuminates it by holding the Control and Shift keys while pressing the right mouse button. This works even if the image itself is not displayed. The last part of the main user interface is the library, where you can find every asset or node available. The library can be customized and rearranged using the icons on the top left. The ones on the right of the panel can be used to search and filter the nodes in the selected folders. There are multiple ways to add nodes to the graph. For example, we can drag and drop most nodes from the library directly into the graph. From the texture generators group, drag and drop any of the patterns to the main area of the graph panel. The next way is to use the shortcuts at the top of the graph panel, which contains only the atomic nodes. These are the most basic functions in the software, such as curves or labels adjustments, gradient maps, etc. Let's add a blend node by clicking on the second icon in the toolbar. If you have the previous node selected when doing so, it will be connected to it on the default input. Otherwise, connect it manually. We need a second texture to blend, and we will add this one with the most common method. Pressing the spacebar when this panel is in focus will open a window that allows searching nodes by name. Go and find the Clouds 3 node and add one of those. As I mentioned, the blend node combines two textures in one of several ways. Those familiar with Photoshop or other image editing tools will recognize most of the blend modes available on the Properties panel. For this example, we'll choose Multiply. I think that with that, we're done with the review of the main areas of the user interface and part 1 of this tutorial. Feel free to add more nodes and play with the parameters, and when you feel ready, skip ahead and we'll make our first material. Hola again! Welcome to the second part of the tutorial. For this example, let's make a lava rock material. Start by creating a new substance graph. The different templates start with different sets of node outputs. For PBR materials, you will generally use the base metallic roughness or one of its variations, which add rendering support for effects such as clear coats, subsurface scattering, or sheen. The parent size and output format control the output texture sizes, while the last option allows you to create the graph in a specific file, in case you have multiple open at the same time. I'm going to start by changing some settings on the 3D view to change how the material is displayed. First, I'll swap the mesh to a Sphere 2 tiles by selecting it from the Scene menu. Then, I'll change the rendering definition from the Materials menu to Tessellation plus Displacement to show the height map. This will display the properties of the material, where I'm going also to increase the height scale to 10 and the tiling to 2. A good method to create complex materials is to start with the height map texture and make the rest of them using it as a base. It is also good practice to start with the macro detail or the biggest shapes and decrease the scale and add micro detail progressively. First, add a Cloud 2 node. This one has a good balance of high and low frequency noise, and it is a good foundation for a rocky type surface. But before moving on, I want to share a useful tip that I like to use to save time. Add a blend node with the opacity set to 0 and mode to copy, and connect its out to both the normal node and the hide output node. Add also an ambient occlusion HBAO and connect it to the ambient occlusion output. This will make it much faster to have a good preview of the hide map without having to reconnect multiple nodes every time that we make a change. I think that this noise is still a bit too much, so let's soften it a little with a blur node. Set it to a low value, like 0.8 or 1. We just want to remove some of the fine detail. This looks alright, but we need to add some round shapes to give it more structure. A Berlin noise is pretty good for this effect, but we need to reduce the scale quite a bit. A value of 5 or 6 will work quite well. If I connect this Berlin noise to the final blend node, we can see that this type of noise is very uniform, but is creating the bigger blobs that I was looking for. Now we can mix these two noises together using a blend node with the mode set to copy and the opacity set to somewhere around 0.5. Let's add a plasma node next. This type of node is similar to a Perlin or Gaussian, but produces long valley streaks and has almost a liquid appearance. We're going to use this to mimic the effect of solidified lava. However, we need to reduce the scale again to be in a similar range to our other noises. A value of 7 or 8 is a good starting point for this node. Use another blend node to combine the previous noises and the plasma. Again, select the copy mode and set the opacity to around 50% or 0.5. Like we did with the clouds noise, let's add a blur node right after the plasma and before combining it with the previous noises. This will soften the edges of those darker valleys and make them look less artificial. Set the intensity of the blur to some value between 2 and 2.5. Here I'm also increasing the hide depth on the ambient occlusion node to match the scale of the material a bit better and highlight the height differences. Let's add some big cracks, scratches and other imperfections to the material. Start by adding two different grunge maps. These procedurally created noises are very useful to represent different types of damage, and there are many variations of them. For this example, I will be using numbers 10 and 12. We don't want to overdo this effect, so next, adjust the balance, contrast and cracks parameters until you get rid of most of the low contrast noise and are left with just the scratches and the cracks. Now we're going to combine these two noises together with another blend, but this time using the multiply mode. And after that, another multiply blend node to mix it with the main height map. On this one, set the opacity to a very low value, like 0.03 or 0.05. Next, we'll repeat the same steps as before, but with a few important changes. Instead of the grunge maps, we're going to use two copies of anisotropic noises. These produce parallel lines with different values and will make perfect rock striations once we distort them. You can leave the parameters to the default values, except increasing the Y amount in one of them and giving them different random seeds. Now blend these two using the switch mode. This mode is similar to copy, except that the values of each image influence their weight. set the opacity of the blend node to 0.5. Now use yet another blend node to combine the lines with the main map. This time, set the mode to multiply and the opacity somewhere between 0.2 and 0.25. Looking good already. Let's add a couple of layers of distortion to make it more interesting. First, add a directional warp and connect the intensity input to our previous blur plasma noise. Next, set the intensity of the warp to a high value, like 90 or 100, and rotate the warp until you get something that you like. As a side note, being able to reuse nodes like this is another advantage of non-destructive graph editing. Back to the material, now repeat the same steps as before, but this time using a Perlin noise with a scale of 14 as intensity input on the warp. Set it to a new angle of rotation and set the intensity to something like 30 or 35. Next, we're going to add a bit more detail and variation in 3 easy steps. The first one will be to blend in a moisture noise. As the name implies, this one is great to represent water damage and some types of erosion. Use the copy mode and set the opacity of the blend to a medium-low value like 0.3. The second step will be to add more cracks and scratches. Since the one we blended earlier are heavily warped, we can reuse the same grunge map blend and save a few milliseconds of rendering time. Set the blend mode to multiply and a very low opacity, between 0.05 and 0.1. The third and final step is to add a regular non-directional warp to move everything a little. Use a new Perlin noise with a scale of 20 or 22 and a very low warp intensity, like 0.06. Now we're done with the macro detail on our height map, but before moving on, let's remap the grayscale values to make use of the full possible range. Use either an auto levels or levels node. If you choose the manual one, move the minimum and maximum input ranges, the black and white triangles at the top, until you get rid of the unused values. Once graphs start to have a larger number of nodes, it is a good practice to group them into frames. To do so, select all the nodes up to the levels one we just added, right-click on any of them and select Add Frame. You can rename it and change the background color if you want. Since the video is starting to go a bit too long, let's keep the micro detail simple. We'll combine 2 different noises, Dirt 1 and Dirt 2, using blend nodes set to add mode and a low opacity, around 0.1. After adding a frame around these last nodes and renaming it, the final step is to add a high-pass grayscale node. This node will get rid of some of the high-frequency noise by flattening it out. Set its radius to a high value, around 60. And this concludes our height map. We will use it to make the base color next. Add a separate gradient map node and connect its input to the height map before the high-pass grayscale node. Next, open the gradient editor from the properties panel. The gradient editor can remap a grayscale image to any color gradient. This gradient can be defined manually, adding control points to the bar at the top and assigning colors to each. You can also edit multiple control points at the same time and change the interpolation mode between different options. However, one of its most interesting features is the ability to define a gradient by sampling it from another image. To do so, click the Pick Gradient button on the bottom right corner and draw a line over any image. In my case, I have an image of lava flow that has a nice mix of colors, but I have to move it to the other screen to keep it visible. Let me sample this image a few times until I get a gradient that I like, and then I'll come back. Here's my final gradient. Feel free to pause the video and take your sample from here if you want. I also went back to the Levels node and adjusted the grade balance to get a bit more of those red tones showing up. By default, this template doesn't include emissive texture math support, but we can easily add it. Create an output node and, in the Properties panel, select Add Item. On the new component that shows up, change the usage to emissive. You can also rename the node by changing the identifier at the top. We'll generate this emissive texture by simply applying a Levels node to the gradient map that we use for the color and removing everything but the bright reds and yellows. And since we just added this new output, the 3D view is not yet aware of it. To enable it, right-click on any empty space on the graph and select View Outputs in 3D View. After doing so, our lava glows and the material is almost complete. Let's make a quick and dirty roughness texture for this material. Since it's a very uniform rock, a grunge map noise mixed with the base height will suffice. In this case, I'm using grunge map 8 and copy blend with an opacity of around 0.3. Finally, I added a histogram range node to reduce the range of grayscale values and push them up a little to increase the overall roughness. Congratulations, this material is now complete. If you want, try changing the rendering mode from the real-time OpenGL based to the ray-traced iRay. You can also experiment with different scene and camera setups, or drag HDRI maps from the library to the 3D view to change the lighting. And if you made it this far, thank you for watching this tutorial. In future videos in this series, I'll cover single techniques in more detail and explain the usage of more advanced nodes. See you next time!